Dear students, Assalamu alaikum. Today in this video, we are going to learn about the graphical representation of the motion. And here we will take the distance time graph and the velocity time graph. In the distance time graph, here the graph is plotted between time and the distance. Time is taken in seconds and distance is taken in meters. Here the time is independent variable and the distance is dependent variable. Let us try to find the graphs which we will obtain in this distance time graph, or when the body is actually lying at rest, or when the body is at rest, or when the body is stationary. तो इन दिस केस डिस्टेंस टाइम ग्राफ में हम तीन केसेस के बारे में इस ग्राफिक्स को स्टडी करेंगे. वन इज व्हेन द बॉडी इज एट रेस्ट, सेकंड व्हेन द बॉडी इज मूविंग with uniform motion, and the third case is when the body is moving in non-uniform motion. In this video we will talk about only two cases, that is when the body is at stationary and when the body is having uniform motion. Let us see what will be the graph, or how we will what is the graph which we will obtain when the body is at rest in distance time graph. देखो distance time, in the distance time graph, तो यहाँ पे we take time along the x-axis and y along the and distance along the y-axis. देखो suppose a body is 10 meters away from its origin. You know, this is the point where the time axis and the distance axis they intersect each other. Suppose एक body यहाँ पे है, it is 10 meters away from the origin. Now, after that means here the body will not change its position after successive intervals of the time. चाहे 1 सेकंड के बाद देखेंगे तो बॉडी यहां पे ही होगी, यानी कि 10 मीटर्स अवे. ठीक, अगर 2 सेकंड्स के बाद भी देखेंगे तो आफ्टर 2 सेकंड्स द बॉडी विल लाई एट द सेम डिस्टेंस, दैट इज 10 मीटर्स अवे फ्रॉम द ओरिजिन. एंड 3 सेकंड्स के बाद भी बॉडी इसी मतलब पोजीशन पे होगी, दैट इज 10 सेंटीमीटर. इसी तरह आफ्टर 4 seconds the body will lie at the same distance, that is 10 meters away from the origin. Here after 5 seconds the body will also remain at the same position where it was initially. So here we noticed that at every instant of the time the position of the body does not change, it remains at rest, it remains stationary. And when we plot the graph in this situation, when we'll join these points, here we get a straight line. Here we will get a straight line. Here we will get a straight line that will somehow running parallel to the time axis. This is the type of the graph which we will obtain when a body is at rest in distance time graph. So this was the first case when the body is at rest. Now we will try to find the graph in case when the body is in uniform motion. Here you know uniform motion means the body is covering equal distances in equal intervals of time. Suppose a body is moving along a straight line path and it is covering equal distances in equal intervals of time. Suppose a body in first second it is covering 20 meters. And in the second interval, it is again covering the 20 meters. That means time interval here is 2 minus 1, that is 1 second. इसमें भी ये कवर करते हैं 20 meters. इसी तरह थर्ड इंटरवल में 60 minus 40, it is covering same distance 20 meters. In the fourth मतलब in this time interval, that is same again, it is again covering the same distance, that is 12 meters, 20 meters. And here we see, here the body is covering equal distances in equal intervals of the time. That means motion in this case is uniform. Let us see the graph in this case. देखो, here we will take the time along the x-axis and the distance in meters along the y-axis. Suppose a body is covering 20 meters after 1 second. Its position will be here. And after 2 seconds, it will be here. That means it is after 2 seconds it is covering 40 meters. So position of the body will be here. And in the third, after 3 seconds, position of the body will be here. That means distance covered after 3 seconds is 60 meters. इसी तरह distance covered after 4 seconds, that is 80 meters. And distance covered after 5 seconds, it is 100 meters. ठीक है? So let us plot the graph between the time and the distance in this case. Here, when we will join these points, we will plot a graph between these between the time and the distance. We will get a straight line that is inclined to the time axis. Okay, so इस केस में ऐसी line we will get a straight line which is inclined to the time axis. This is a graph which we will obtain in this situation when the body is having uniform motion. In case of distance time graph, we will get a straight line that is inclined to the time axis. Now, from this distance time graph, when a body is moving in uniform motion, we can find out the speed of a body. See how we can calculate the speed of a body in this case. Suppose we will take a small portion AB of this graph. Suppose A and B. From both the points, that is A and B, draw lines parallel to both x-axis and the y-axis. इन दोनों पॉइंट्स से हम लाइन को एक्चुअली परपेंडिकुलर लाइन डालेंगे, यहां भी और यहां से भी हम इसके ऊपर परपेंडिकुलर लाइन डालेंगे. दैट मीन्स दोनों पॉइंटों से हम पहले एक्स एक्सिस पे परपेंडिकुलर लाइन डालेंगे एंड फ्रॉम द बोथ पॉइंट्स वी विल ड्रॉ द परपेंडिकुलर्स ऑन द वाई एक्सिस एज वेल. यहां पे भी हम परपेंडिकुलर लाइंस डालेंगे वाई एक्सिस के ऊपर. It will be a bit here. Yes. हाँ, देखो मैंने आपको बताया we can find the speed of a body from this distance time graph when a body is moving in uniform motion. Let us take a small portion AB of this distance time graph, that is AB. From both points, that is A and B, draw lines perpendicular to both x-axis and the time axis. Now, here at time t1, distance covered will be s1, and at time t2, here the distance covered will be s2, suppose s2. Now after time, that is t2 minus, after time interval, after time t2 minus t1, here after time t2 minus t1, that is this t2 और t1 के बाद मतलब what will be the what will be distance covered? It will be s2 minus s1, distance covered is s2 minus s1. Here you know speed is equal to distance by time here. Distance covered is s2 minus s1 and time after time interval of t2 minus t1. t2 minus t1 means this यहाँ से t2 from this to do minus यहाँ से यहाँ तक, it will equal to AC. Here the time is equal to AC and distance after time interval t will be equal to s2 minus s1. That is it will be equal to s2 minus s1, which is equal to BC. And time interval is t2 minus t1, t2 minus t1, t2 यहाँ पे भी हम लिख सकते हैं t1. It will be actually equal to CA, यानी कि यहाँ से यहाँ तक इसको ये वाला टाइम हम सब्ट्रैक्ट करेंगे, वहाँ बचेगा AC इंटरवल. Now you know BC, if we will actually join these points, we will get a right angle triangle here. You know the BC here, it is perpendicular and AC is the base of the right angle triangle, and you know the perpendicular by base is always equal to tan theta. So here speed is equal to tan theta. That is BC by AC here represents the tan theta. This tan theta, it represents the slope of the graph, and this slope of the graph, it gives the speed of a body when it is moving in uniform motion in this distance time graph. So from this distance time graph we can calculate the speed of a body. So here we have find it out that the speed is always equal to the gradient or to the slope of the graph, which in this case is equal to tan theta. अब जितना ये स्लोप ज्यादा होगा, स्पीड ऑफ द बॉडी विल बी मोर. जितना ये कम होगा तो स्पीड ऑफ द बॉडी विल बी, सपोज इन दिस केस इफ विल टेक दिस इज सपोज टाइम in seconds, this is distance in meters. अगर हम दो बॉडी लेंगे, एक ए बॉडी है, दूसरी बी. यहाँ बी बॉडी का जो एंगल बनता है दैट इज थीटा, सपोज थीटा 1. जो ए बॉडी बनाता है इट इज थीटा 2. In this case theta 1 is greater than theta 2. इसका मतलब है speed of the body, speed of the second body is more, that is speed of B is greater than speed of body A. So this is regarding the second case when the body is moving in uniform motion. So today in this video we will conclude here. In the next video we will try to learn about when the body is in non-uniform motion in this distance time graph. Thanks.